Hey, what's up? It's your old pal, Mr. Cook, and we're going to work on the Unit 6C extra review right now. So just make sure that you have out a calculator, and make sure that that calculator is in degree mode. So to go into degree mode, just to remind you, we just hit the mode button here, and then we just make sure that the degree function is highlighted. If it isn't, then just simply scroll over to degree, hit enter, and then you can quit out of it. So hit second in mode again. It's important because we're just dealing with degrees with all of our angle measurements for these triangles. So with the triangles, we're going to be using the law of sines and the law of cosines. So, you know, just it's helpful to have those formulas. They'll be given to you on the test, but, you know, you got to know what they mean. So, yeah, just make sure that you are familiar with them. I'll write them at the top here. And then the angle 1. There you go. Okay. So we start off with this scenario where we have two angles and a side. We're going to solve the triangle, so we need to find all the different sides and angles. So the first angle, angle A, we can find really easily because all three angles inside of a triangle add up to 180. So all I have to do is just take 180, subtract away 53, and subtract away 61, and that gives me the measurement of angle A. And let's see what that is in our calculator. 180 minus 53 minus 61, and we get 66. So 66 degrees for that angle. Just maybe add it into the diagram if you need it. And then the other two sides that we can find are X and Y. Let's just call them those. So there's our angle. Now for the sides. So to solve for, let's see here, let's solve for side length X. We're going to use the law of sines because we have a side and angle pair here. So we do the sine of 61 over its opposite side, 23. And that's proportional to the side X, right? And its opposite side, opposite angle, 66. So sine of 66 degrees over its opposite side, X. And then we can simply just solve this by cross multiplying. And you know, getting X by itself. So if we cross multiply, then we get X times the sine of 61 is equal to 23 times sine of 66. And then divide both sides by the sine of 61, and you get X is equal to 23 times the sine of 66 over sine of 61. Type it into your calculator, and you get approximate answer. And, you know, round your answer to at least 2 decimal places. So let's see what we get. 23 times sine of 66 divided by sine of 61, and enter, and then we get our side length, which is 24.02. So there's our first one. And this process of cross multiplication is going to be the same for the next one. So I hope you don't mind. I'm going to set it up and then just kind of solve it on my calculator. So the next one that I do is the sine of 61 over its opposite side, 23. And then that's equal to the sine of the other angle, 53, over its opposite side, y. So when I cross multiply here, I end up with y is equal to, and then that'd be 23 sine of 53 over the angle sine of 61. So then I type that into my calculator, and I get my other answer. So 23 sine 53 divided by the sine of 61. And I get 21.0018, so that's about 21.00 for the side lengths. So those are the other two sides, and at that point I'm all done because I got the missing sides and also the missing angle measurement there. For number 2, it's basically the same kind of setup. If you look at it, we've got two angles and then a side. So if I have those two angles, I can find the third one real easily, again, by just subtracting from 180. So I take 180 minus 34 minus 32, and that'll be angle B. Let's see what that's going to be equal to. So 180 minus 34 minus 32, and that gives me 114. So that's a 114 degree angle. There we go. And then once again, we can just use the law of sines because I just found an angle and a side across from it. So I can use law of sines to set up that proportionality. Sine of 114 over 31 is equal to, and then let's make variables for these side lengths, x and y. So let's solve for x first. So we do the sine of 32 over its opposite side, x. Then we cross multiply and solve, and we end up with the following. x is equal to, and then it'll be 31 sine of 32 degrees over the sine of 114 degrees. And let's see what we get on our calculator with that one. So 31 times the sine of 32 divided by the sine of 114. Enter, and we get our side length, which is 17.98. Now let's go ahead and solve for y. So, quite similarly, we're using the same ratio. Let's do the sine 114 over 31 is equal to, and then it's going to be sine of 34 over y, because that's the angle that's across from the side length y. By cross multiplying and solving, we get y is equal to 31 times the sine of 34 over the angle sine of 114. And let's see what that is in our calculator. So 31 sine of 34 divided by the sine of 114, and we get 18.98. All right, so there's our missing angle and our two missing sides, rounded to 2 decimal places, and we're done with the second one. You can see that these ones take, if you, like with all the steps and all that stuff worked out, just like a couple minutes. I know that we have, how many solved the triangle ones? 10 of them, but a lot of them are pretty easy, especially when you start getting some of these calculator prompts down. You can get them done in like a minute or so. All right, so now we've got two sides and an angle between them, so the only thing that we can solve for is this missing side over here, so we're going to use the law of cosines for this one. So using the law of cosines, x squared is equal to the two sides around the angle squared and added together, minus 2 times each of those sides, so 27 times 29, times the cosine of the angle between them, which is 93. All right, so we just type that stuff into our calculator and we get x squared. So let's see what that's equal to. 27 squared plus 29 squared minus 2 times 27 times 29 times the cosine of 93. And we get 1,651.96. But obviously we need to take the square root of that to get x all by itself. Oops, let's go ahead and write the little about to equal to signs on there too. There we go. All right, so when we take the square root of that, we get about 40.64. So that's our side length, 40.64. All right, there's one of our missing sides, actually our only missing side. Now let's find some of these missing angles. So what we're going to do is use that side and the angle across from it and use the law of sines to solve for one of these angles. So I do the sine of 93 over the opposite side x, and that's going to be equal to, and then let's solve for angle, whatever, let's solve for angle A. So the sine of A over its opposite side, 29. So, the only thing that we need to do is get the sine of A by itself, so we just multiply the 29 over there. So we end up with 29 times the sine of 93 over the x that we have there is equal to the sine of A. All right, and then we just type all that into our calculator. So there's a neat thing that you can do on your calculator if you have a value like, that 40.64 that you want to do, like, get really accurate answers, and you can store that as a variable value. So what I'm going to do is I'm going to store this number on my calculator as x, and here's how you do it. You just use the store button, which is in the lower left corner right there next to 4 and 1. So we just hit store, and it stores the previous answer as anything I want. So I'm going to store it as x, so I'm going to press the x button. Now every time that I use x, it's going to use that 40.64428.751 and so on, whatever it's saved down to. So when I type this in, that's how I'm going to use that x value. So I do 29 times the sine of 93, and then divided by the number that I just had, x, the 40.64 whatever. And then I'll get my answer. So the sine of A is equal to about 0.71253. Now, if I want to get A all by itself in this case, I need to undo the sine part of it. So to do that, I need to do the sine inverse. So do the sine inverse of this, and that just leaves A by itself. And that'll be equal to the sine inverse of this decimal value that I have, 0.71253. So if I use that on my calculator, I get my angle measurement for A. So sine inverse of that number that I just had, and I get the following angle measurement, 45.44. And that's degrees. So make sure you have the units on there. Okay, so we have this missing angle measurement of A. And we also know that this angle is 93, and all three of these angles have to add up to 180. So the easiest way to solve for B is just to take 180 subtract away 93, and then subtract away the number that we just had, that 45.44. All right, so let's see what that angle B is equal to. It'll be about equal to what? So 180 minus 93 minus the number that we just got, just that last angle, and we get about 41.56. So 41.56 degrees is going to be our answer. And don't forget to put degrees on there because those are units, and units are important to include, you know, when you're getting these answers. Okay, a couple more, and yeah, and then we'll conclude this video. Let's just do this one side for this video, and then we'll do the other side on a shorter video. Okay, so the next part is the easy stuff. This is when we have all three sides, because we can just continually spam the law of cosines formula for solving angles. Here's how it's set up, and there's a little bit of a rule that you want to go, a rule of thumb. You want to solve for the largest angle first. So the largest angle is always across from the largest side, so if the largest side is 29, the largest angle is A. So I'm going to solve for A using the law of cosines. So A is equal to the cosine inverse of, and then it's a fraction, and it's going to be the sides around the angle squared and added together, so 21 squared plus 13 squared, minus the side across squared, all over 2 times 21 times 13, so the sides around the angle. And then the nice thing about this is it's just all calculator work. So you can just type it directly in, cosine inverse of, and some of your calculators, the really nice ones, you can just hit alpha y equals, and then you can just hit n over d, and that turns it directly into a fraction. So I can write it in like that, 21 squared plus 13 squared minus 29 squared over 2 times 21 times 13, and then enter, and that gives me my angle measurement. So the first angle that I get, angle A, is about equal to 115.03 degrees. If your calculator doesn't have this option, it's not a big deal. Like some of the TI-83s, TI-83 pluses don't have that, and some of the other TI-84 pluses don't have that built into it. All you have to do is just type it in, but make sure that you group together the numerator and denominator. So let me show you what I'm talking about. And this is very important, so take note of this if you have one of those calculators. You put parentheses immediately and then group the top stuff together. So 21 squared plus 13 squared minus 29 squared. And then, so group together the numerator and then divided by, and then group together the denominator as well. 2 times 21 times 13. And you'll end up with the same answer. See? If you don't include the parentheses, you will not get the same answer. You'll get an error message. So just make sure that you put those parentheses in there. Okay, anyways, if I just want one more angle, let's get angle B, and then we just subtract from 180. So angle B, I'm going to use the law of cosines again. So cosine inverse of, and then a fraction. So it's the sides around the angle. I square them and add them together. So 29 squared, 13 squared. And then subtract away the side across from it squared, so minus 21 squared. All over 2 times 29 times 13. All right, and then you just type it into your calculator and you get your other angle measurement. So let's see what that's going to be equal to. So cosine inverse of parentheses 29 squared plus 13 squared minus 21 squared parentheses, and then divided by parentheses 2 times 29 times 13. And then enter, and I get my angle measurement, 41.0, maybe 01, yeah, 01 degrees. And then to get the last angle, C, I just subtract those two from 180. So 180 minus 115.03 minus 41.01, and that'll give me my approximate angle measurement for C. Let's see what that's equal to. 180 minus 115.03, oops, 115.03, there we go, minus the angle that we just got, and that gives us around about 23.96 degrees. And that's all three of the angles that we needed. So that completes the triangle. All right, so that's the first 4 problems. And we've gone through all the steps. Really, you know, it's these same steps over and over again that allows you to solve. But there are some cases where you need to watch out because there's a little bit more than meets the eye with these problems. And that's what's going to lead us into the next couple problems that we see when we address the ambiguous case. So let's draw up a couple of these diagrams and let's point out which ones are going to give us ambiguous case. So ABC, angle A is 102 degrees. and then BC is 25, so that's the side across from it, and then AC is 21. Okay, so that's one diagram. Let's draw another one for number 6. Okay, so if I have ABC, angle B is 32 degrees, AB is 33, and then BC is 32. All right. And then for number 7, oops, there's our triangle, ABC. AC is 14, AB is 8, and angle A is 89 degrees. And then here's this one, so triangle ABC. AB is 17, AC is 21, BC is 16. Okay, and then on the back a couple of them, so let's put together those triangles as well. ABC, angle C is 78 degrees, BC is 15, angle B is 55 degrees. And then number 10, ABC, AC is 19, BC is 12, and then angle A is 102 degrees. Okay, so here's how the ambiguous case looks on one of these triangles. If you're given one angle, a side across from the angle, and a side right next to the angle, that gives you the possibility of having an ambiguous case of the law of sines. So number 5 fits that bill because we have an angle, a side across from it, and a side right next to it. Okay. There's another case on here, another ambiguous case problem, and that is number, looks like 10. We've got an angle, a side across from the angle, and a side right next to the angle. So let's look at this one first. Usually you should be able to put together a triangle with this information, but in some cases you actually put together potentially 2 triangles or no triangles as well. Here's a case where we have actually no triangle that we can put together. It's because we have an obtuse angle. The side across from it is 12. The side next to it is larger than that. So like, remember what I was talking about earlier with the largest side is across from the largest angle, the smallest side is across from the smallest angle? What this implies is that if there's a side that's bigger than 12 across from this angle, so number 19, for example, 19 is bigger than 12, that means that this angle B has to be bigger than this angle A. And that's troubling because if it's more than 102 degrees, then they already add up to more than 180 degrees. So actually with this setup that we have over here, it's not possible to make a triangle with this information. So we can just write not possible for this one, and we're all done. Isn't that crazy that a situation like that can present itself with this? So this one has an obtuse angle, and then a side across from it is bigger than the side next to it. That's good. So that means that there's only one way that we can make this triangle right now. And even if this was an acute angle, that'd still be true. You know, if this was like a 52-degree angle, I could still make only one triangle out of this. So as long as the side across is bigger than the side that's next to it, then that means that we're going to get only one triangle. The only case that's weird with the ambiguous case with that setup is if it's an acute angle and the side across is smaller than the side that's right next to it. That's a case where we get 2 triangles. And we'll see one of those in the group work. So make sure that you check out the group work problems for a couple of examples where we have 2 triangles. Luckily for all of these, we don't have 2 triangles, so we can just go about it business as usual. Okay, so the nice thing about number 5 is that the way it's set up, you can only solve for one thing, and that's you can use the law of sines to solve for this angle B. So that's what I'm going to solve for. The sine of the angle B over its opposite side 21 is equal to the sine of the angle 102 over its opposite side 25. So for this one, I just cross multiply and solve, and I end up with the following eventually. Sine of B is equal to 21 times the sine of 102 over 25. So if I type that into my calculator, let's see what I get. So 21 times the sine of 102 divided by 25, and I get 0.82164. And then if that's equal to the sine of B, to get B by itself, I need to do the inverse sine of that number. So B is equal to about what? Let's see here. So sine inverse of that number, I get about 55.25 degrees. So now I've got angle B, 55.25 degrees. So now I can find angle C real easily because all three of these angles have to add up to 180. So C will be equal to 180 minus 102 minus that 55.25 degrees. So let's see what C is about equal to. So 180 minus 102 minus the angle that I just found. So I get about 22.75. So 22.75 degrees. So that gives me my angle measurements that I'm missing. Now I'm just missing one additional side, and luckily I can just use the law of sines for that. So here's what I would do. I would take that angle measurement, 22.75, and I'd call this side x. So what I do is sine of 22.75 over x is equal to, and then let's use the side and angle that we have, that we know that it's given to us. So that's sine of 102 over 25. So then by cross multiplying and solving, I get x is equal to, let's see, that'd be 25 times the sine of 22.75 over the sine of 102. All right, so I type it on into my calculator, and I get an approximate answer. So let's see what we get. 25 sine of that angle that I just got there, divided by the sine of 102, and I get real close to about 9.88. So 9.88 for that side length over there. And that's my last side on my triangle, and I'm all done. Okay, now on to number 6. Let me kind of make some space here for number 6. There we go. Okay, number 6. So we've got an angle, and then we have two sides around it. Oops, I just rounded 33. Kind of like separated it from the rest of it. So there you go. Let's just put that there. There we go, 33. All right, so with this current setup, I can't use the law of sines at all, but I can use the law of cosines to solve for this missing side, x. So I do that. X squared is equal to, and then it's going to be these two sides squared and added together, so 33 squared plus 32 squared minus 2 times those sides, so 33 times 32, times the cosine of the angle between them, which is 32 degrees. So I just type this into my calculator, 33 squared plus 32 squared minus 2 times 33 times 32 times the cosine of 32, and I get this number, 321.92, and that's equal to x squared. So to get x by itself, I just take the square root of that, and I get my answer, which is 17.94. So there's my side length that was missing. Now the only thing that I need are the two angle measurements, A and C. So what I'm going to do is use the law of sines with this side and angle pairing. So I do the sine of 32 degrees over the side that I just found, 17.94, and that's going to be equal to the sine of A over its opposite side, 32. All right, so then, I just cross multiply and solve, and I end up with the following. Sine of A is equal to, and then it's going to be, let's see, 32 times that stuff. So 32 sine 32 divided by, oops, not to the power of, divided by, and then it's just round it, 17.94, whatever. And then we get about 9.94523. So then what we do is we do the sine inverse of that number, and we get an approximate angle measurement. A is about equal to, 70.95 degrees. And once we have that angle measurement of 70.95 degrees, we can easily find C by just subtracting from 180. So C is going to be equal to 180 minus 32 minus that 70.95. And we get a pretty close approximate answer. Let's see, 180 minus 32 minus 70.95, and we get 77.05, round about there, right around there. And then don't forget that's degrees for that angle measurement. So we've got the two missing angles and the missing side, and we're all done with number 6. So I'll just do these two, and then I'll call it, and then we'll say that's the end of the video for this one. So number 7, we have two sides and an angle between them. So once again, we can use the law of cosines here. Let's call this side length x. So x squared is equal to 8 squared plus 14 squared minus 2 times 8 times 14 times the cosine of 89. So type that into your calculator, 8 squared plus 14 squared minus 2 times 14 times 8 times the cosine of the angle between them, 89. And then take the square root of that, so we're going to be pretty close to 16, it looks like. Yeah, 16.0, so x is equal to 16.00 or about equal to, I guess. All right, so now we have this side length over here. So now we can solve for these angles using the law of sines again. So the sine of 89 over that number, 16.00, is equal to, and then let's find one of the angles. Let's find angle B. So the sine of angle B over its opposite side, 14. So cross multiply and solve, and you get the sine of B is equal to 14 times the sine of 89 over that number that we just found, 16.00 whatever. And then we end up with that ratio, 0.8747. And then we do the sine inverse of it, and we get our angle measurement, which is 61.01 degrees. So B is equal to 61.01 degrees. That gives us this angle here, 61.01. And then to find angle C, we just subtract, we take 180, subtract away 89, and also subtract away 61.01, and we get our angle measurement. So C is about equal to what? 180 minus 89 minus the number that we just got, and that's 29.99 degrees. So we've got the two missing angles and the missing side, and we're all done with number 7. Okay, last one, number 8, and this happens to be the easiest of all the setups when you have all three sides of a triangle. Because this one just, again, you can just use the law of cosines to just find all the answers, just like what we did in number 4. So let's find the largest angle, B. So B is equal to cosine inverse of, and there's a big fraction there. So it'll be 16 squared plus 17 squared minus 21 squared over 2 times 16 times 17. Type it into your calculator and you get your answer. So let's do that fancy little fraction button that we have on the calculator. So cosine inverse of, and then alpha y equals 16 squared plus 17 squared minus 21 squared, all over 2 times 16 times 17. Enter and you get your angle measurement. It's right around about 78.98 degrees. So there's angle B. Let's find the next biggest angle, which would be angle C across from the next biggest side. So C is equal to the cosine inverse of, and let's make another fraction there, and then it'll be 21 squared plus 16 squared minus 17 squared over 2 times 21 times 16. Type that into your calculator. So cosine inverse of 21 squared plus 16 squared minus 17 squared, all over 2 times 21 times 16. And that's about equal to 52.62 degrees. So there's our next angle measurement. And then, of course, to find the third one, just subtract from 180 because they're all going to add up to 180. So A equals 180 minus angle B and minus angle C. And what do we get there? So 180 minus 78.98 minus the angle that we just got, and we get pretty close to about 48.40 degrees. There's our last angle, and that completes the first side. And I think I was pretty clear on saying that, like, you know, you're obviously not going to have this many of the solve the triangle problems. This is just, you know, practice as much as you possibly can. Yeah, so a bunch of, you know, different problems, but obviously the methods are pretty much the same. So if you got you know, the method down for this, the rest of it's pretty easy. All right, that's it for this video. Let's go on to the back page for the next video.